Hello, Mike 0 Kilo November Mike here, and if anyone has been keeping up to date with my my Facebook group, you will understand that I have a project I want to do, and it was the thing that I posted on the Facebook group was a picture of this. If we can get it in camera. Now I said what can it be? So someone at my club brung in something, and they've been doing a bit of research and whatnot, as I have now as well, and they brought in a server power supply, and they said you can modify this to work at excuse me 13.8 volts and whatnot, and you can make this basically a power supply for radio. Now, the one thing about these power supplies is, especially the one that I was given, because I was actually given it, the power supply, I was given by a member of my club, and he said because I showed interest in wanting to do something with it, he said, here it is, and you can buy these off of eBay, £25 in the UK, sometimes even cheaper, depending on what one you get. Now, the one that he gave me was this one, the 1400 watt, and it is the HP HSTNS-PD43. It's a 1400 watt supply. And it will deliver 12 volt, it will deliver 117 amps. Now, if you go onto YouTube and you search up, conversion, server power supply conversion, something like that, you'll come up with a lot of these. And there was one individual that I've watched, and I'm subscribed to him, was BBD amplifiers, I think it is. BBL amplifiers, I can't remember what it is now. And he's done something in the US. He's done something with these, and he's done a major big 1000 amp power supply. And he's put 10 1200 watt versions of these power supplies, and he made a great big power supply and then tested it. Now, that got me intrigued, and I've been doing a bit of research and wanting to do something myself. So after getting it, I've spent the last week or so doing a bit of research online, and I've bought a load of bits and pieces, including that case you see, and we've got ourselves some resistors. We have got a little plug for plugging it in, and I have got amp and voltmeter with a 100 amp shunt. Now, you can convert this to, say, 13.8 volt, and 13.8 volt, it will be about 100 amps. And the good thing about these is you can daisy chain them together. It's the nifty little feature they've got as load sharing. Now, in coming projects, I am going to do some other projects. We're going to start with this, and then I'm going to build basically a load tester. I need a load to test it to 100 amps. With the big supply that this bloke made, 1000 amp supply, he was doing, well, he actually tested it well past 1000 amps. It was pulling about 1400 amps, but he sat 1000 amps for an hour And the only thing obviously is the only thing that was really bad was the noise of the fan. Apart from that, it enjoyed it. It done what it was supposed to have done. So this video is going to be a bit long. I'll try and keep it as short as I can, but it is going to be long. But it's going to be a video solely modifying this power supply and then building it into that case. Because eventually, at the end of it, I want a ready power supply. So that is what we're going to do today. So we're going to crack on. I'll show you it down here. If I can just move this down. We'll go to about there. And I think we should be able to go like this. There we go. Right. So this is the power supply. 1000 amps. I've already stuck a little switch on it. From what I can see on the internet, if I get a little pointer, all we do, I have got to do a bit more testing, but what we do is there's 2 pins here, and then there's 2 pins here and then 1 single pin here. So the first 3 pins, the first pin at the edge here, you put a wire, and the next 2 pins across, you bridge them to be able to make the power supply start up. So basically we put a AC inlet here and then switch our little switch on here and it fires up, and 12 volts, it's actually 12.2 volts, obviously comes out of out of here. Negative this side, positive this side. So hopefully we'll get on it. Now if we can bring my little, it's not very good, but I have got a little like microscope that we can look at this. And if we go to here, about here, and then we go into the microscope. Now this is going to be a little, right, we want about here. So let's try and focus in a bit more. There we go. Right. Right, so what we want to do is we want to put, I've got some notes as well down. So if I go into my notes, because I've been doing lots and lots of jolting notes down. Issue project. So the voltage resistor, which is 22K, we need to put a resistor between this little, oh, where are we? This one here. We need to go from the leg here, and then if we come across here, you'll see 5 little tags, right? And we got, see, 1, 2, 3, 4, and that's the 5th one. So I've made little solders already ready for me to put these on. So we need to go from this one here, a 22K resistor from here. Okay, we need to go onto this here. Okay, once we've done that, under here, we're going under here. Where are we? Here. Under this one, under the second one, let me get my little tool. So under this one here, this one, number 1, number 2, that is. So under here, we need to put here, we need to put a 6.8K resistor going from here and going all the way. Let's get my notes. Down to where are we? Down here. And as you can see, I've already put a little bit down here. we have to put it onto this one right here. Okay, we'll get rid of that bit. That's where we have to put it onto. So it's on the third leg. 1, 2, 3. So on the fourth one on the bottom. That is where we need to put it. Onto that one there. Now, I may not, well, I may not do the video of this part because firstly, my soldering skills are not brilliant. I will certainly say that now. This is basically a learning project for me. If it works, brilliant. But we're going to find out if it works on this video. This is my first time doing it. I've never done it before. I've done a lot of research. Done a lot of research. Watched a lot of videos on them. Found out the two resistors that I need, the 22k and the 6.8k. They're the ones I need, so I'm going to put them on, and then we shall come back on, you know, back to the video and have a look. So let me put these on, and then I'll come and show you what I've done. Right, so we have done the work, and what I'll do is I'll just show you here on the meter what I've made it. So you may need to turn the device the other way around just to be able to see it, because this is the only way I'll really get it in shot that we can that we can see. So you'll see the meter here, and then I'll turn the unit on. So if we just turn this on, there we go. Right, so it's turned on, and if I put a bit there, and let me just get into a position where I'm not blocking the camera. We put one here and one here, and as you can see, we have 13.83 volts. 13.83 volts, which is I'm not sure whether I'll turn that up a little bit more under a load or not. I need to test it under some sort of load and see how we see how it goes. But as you can see there, literally 13.83 volts, not going anywhere. And you won't be able to hear it on the microphone, but it is silent. So I'll just turn this off, and what I'll do is we'll get this out of the way for a second, and then we'll take a closer look with the microscope of what I've done. So let me just unplug that, and then we'll go to the microscope. So yeah, for the microscope, I have to take my microphone out of the way. Now, the work, my work is not brilliant, but it works. So had a little bit of trouble. It was quite fiddly to do. So this one, as you can see, so the heat sink, the heat shrink, I was trying to repair a certain part of it, and I used my heat gun, but didn't have the nozzle on, and it got too hot and burnt the heat shrink. But like I said, this is just a little testing, see how we get. So we got there, and it is on there. Okay, so that one's nicely out of the way, and then here. So if I can grab something, as you can see, under this one, where are we? Here. Under this tab here is a resistor. Now, when I was doing this originally, the resistor come off. I put too much heat on and the resistor come off. Couldn't find it, so I had to go and buy some more and get it on. So basically what we want to do is on the bottom end of this resistor, you need to, for us, we have put on a 22k resistor. This resistor here is a 6.8k resistor, and then this resistor here is a 22, I think it is. I'm sure it's 22. Yes, it's 22k resistor. So we have to put it on the bottom of the resistor here, the bottom leg of the resistor, and then if we follow this down here, all the way down here, and you'll see set pins here at the bottom. The 1, 2, 3, and the fourth one here. So along on the fourth one, right, which is a ground pin, we have to then solder the other end of the resistor onto there. Now, as you can see, it's not the best job in the world. It was a lot of work, and as you can see, the resistor next to it, I had a bit of trouble here as well for this one. As you can see here, so it's not the best, but it is working as you see. So let me just change the view to that one. All right, there we go. So as you can see, we have got, I just want to move this out of the way over here. We have got it up and ready. So what I want to do now is to put the case all back on. I want to put the case back on, and we need to have a look at the case now. So let me put this this case on. I've got some little legs I need to put, if I can just show you. So I've got some little legs to put in on this. I think it's this one here, this one here, and then this one up here. That is to lift it up a bit so I can get the power cord in. So hopefully I will show you that as we go along. So I'm just going to put this this back on, and then we'll show you it in a second. So we've got that all now back on. Don't worry about this. We are changing all of this. This is just for testing purposes. Now I have got for this project basically is it a right angle? I think it's a right angle. Basically kettle lead plug. But when we put this on here, it goes down. Now rather than take out the little socket here and then wire it all in that way, we would do it this way. So it's more easily maintained. Okay, these are the, move them out there. So as you can see, when it's when it's down on the floor, it would be quite bad on the angles. So rather than do that, I've got these little tiny standoffs that what I'm doing is, on the bottom here we have screw here, and screw here. You can't really see too much because of the glare, I'm sorry. So what I want to do is we will take these off and put these ones on. There's one there. Pretty sure this is how I put it on. I couldn't remember fully how I put this on, because this project is taking a little bit longer than I expected, just because extra parts needed, things like that. Now pretty sure that is okay. Yeah, pretty sure that's the one there. When this goes flat, as you can see, it's flat. Now obviously there's not one here on this side to make it even, but when it is bolted in, it is going to stay you know, still. So that's the way it's going to go. It will go into the box. Let's get the box here. I'll just step that to the side a second. As you can see, we've got the box here. Now it's already undone. I just need to flip up the sides. Put that in a second. I shall show you the little cutouts I've got as well. So this, ideally, is going to go into here. Now eventually that will be a different switch and that will go to there. Might be better for here. And I'm going to try and put that about here. Just so there's enough room this side so I can get some cables on here, and that will go to the back here. And then enough to get the side on here that doesn't interfere with the power cables to there. So I'm hoping that that is exactly where I want it to go. Now, how I'm going to do this is I've thought of a way of doing it. So put this here. Running out of room now. So, also, obviously, this here is going to be the front, kind of like that. So I've made up little bits of paper that I've cut out to here. So what I'm going to do is I'm going to cut these out, right? And then I can mark out where the bits need to go. And then that way, when I come to cut it, it'll be where I want it to be. We do need to make sure, obviously, they're level. Pretty sure I've done the same distance from here to here, so that should be good. And then obviously this isn't the back, but it is the back. This will be the same, but on the back end. So when it comes to the back, it will go on this end here. I've done it like this, so I've kind of looked at it and gone AC down here with a switch, and then the two terminals here. I want to leave a space down here because eventually I want to see if I can do some like Anderson power poles, but I need to figure out what ones are able to take, you know, at least 100 amps. They do some, I think it's 120 amp, but I'm not sure how they work. I've never messed around with Anderson power poles, but this would, like I said, it's a project. It'd be good to do. And then, as you can see here, I said fan, but the question mark. I'm not sure whether I put maybe like an 80mm fan kind of here, pulling air out. Not sure about that just yet. That might come afterwards, you know, when I come to do it. Now, when it comes to this, the only way I thought about doing it was with masking tape. Now, if I put masking tape across here and then measure out the holes, we can then lay into the box and drill the holes to where we need to put them, and that's where it should be all good. So I now need to get my tape, so I'll be back in a second. You can see we have, get out of the way, we have drilled our 3 holes there, and we've deburred them, taken off all the sharp edges as well. So now I need to put these on, and these will go in That one there, that one there. And that one there. Right, now I get a screwdriver. That is not a very good screwdriver for that. Under my tools. Take these out. Is that one a good one? That one's a good one. Change that out for that and put these back into here. Lost one on the floor. Right. So now we need to put these into here. Hopefully this, I've done it in the right place. That is what I'm hoping I've done. There. So that one is there. With these are might have to redo or burr out the holes a bit more, because that could we do it? Ah, we can. There we go. So that is now in place. And hopefully, if we just put all of that in there, what I need to check is if the case lid goes on. And it does go on. Now, I don't know whether you can just see, right there is the little, is the power cable just there. So it does just go on. Is brilliant. Just what I wanted. Now, what I've got to do is think about where we are going to put things now. Because I've got a few things to put in here. If I just get them. There are some lights to go as well, but we'll have to thingy them. I think I'm going to have to order some more parts, because we've got a shunt to fit as well. Now the shunt, ideally, I want to try and get maybe down here. So if we can go like, yeah, somewhere like there, you can just see that in the camera. If I can put the shunt kind of there, I don't think in this supply, in this case, there is really anywhere else to put it. I think, because I certainly won't get two supplies in this case. Now, I could get two supplies in this case if I put these right on the floor, but this wasn't long enough. this would need to be a little bit longer, so I could get a normal kettle lead plug in here. And then I'd be able to maybe put, you know, two on top of each other. But I think we're going to put the, because I could go under. No, I think we're going to go over the top to this bit, because this is the live that will go here, and then that one can go kind of there. So I do need to get, I have got some spacers for this to go on, but that won't work for this. I need some nylon nuts, nylon nuts and bolts to be able to do this. We also need some crimp connectors. We also need some crimp connectors. So the next bit now is I want to do the front panel. Now the front panel will obviously hold the switch, which will be this side. It's not going to be this switch, it will be one of these. Simple on-off switch. It needs to hold the switch here. So that will be our next bit now. So I'm going to mark out the front panel and then we'll come back. Right, so I've pulled these off and I've done the little markings out that I want to do. So that's where the meter will go and that's where the switch will go. This is where the AC inlet will go, and these two are the terminals. I haven't yet put in the switch that I think I'm going to put in here. I haven't done that just yet. What I will most probably do is, because it's the same size switch as the front panel one, it's exactly the same size switch. So when I do this one, if this turns out to be the correct size, then what I'll do is I'll then put it onto the end of here, because that's the way it's going to go, and the inlet is going to go there at the bottom along with the switch, and then this side will be where the terminals will be. So we're going to go and cut these out, and then we'll be back and I'll show you it all cut out. And hopefully we can then put in the meter. We can just slip the meter in, because we don't really need, we're not going to wire everything in just yet. So we can slip the meter in and the switch in, and then we can come back. So we'll do that, and then we'll come back on and have a look. So got these cut out, and the first one, as you can see, we're going to put like this. So I've put the the meter and that in to test it out, to make sure it in and it stays there. It's quite a heavy, it's quite a really snug fit. It's really difficult to get in. So I've had to take off the little lugs that are on the side here. I've taken them off and it's really tight to get in. So once I push it in, I'm also going to use a little bit of super glue to keep it in place as well. And the same type of thing with the switch. The switch is very tight going in here, but just to give it that extra little bit, I'm going to put a little bit of super glue on it. But with these, I haven't taken off the little tabs. On this one, it does fit in nice and snug. So that's what we've done on that one. And then the back one, what I have done is I have actually put it in to you. That's upside down. This was a bit better. So this is a very tight snug. Took quite a bit to get that in. I'm not sure if this will, there we go. So that took quite a bit to get in there. The little latches are still on there, but I've had to pull them out a little bit to make sure it stays there, and it's nice and, you know, tight in there. So now I'm not sure, because what we need to do is we need to drill the holes for the terminals. Now the terminals, just move these because I've got a little bit of an issue. Now I have got some cable underneath my desk. In fact, I'll get it. So we've got this cable here, okay? With this cable, the little lugs do go through the hole. All right. This is, oh, what cable was this? 8 gauge, 105 degrees C. Now I've had a little search. I've done the old AI search. 2 of these cables, like it is connected as it is, will take 100 amps quite easy. So I'm in 2 minds whether to use this, just because they go through the little lugs, or I have got a little bit. Now I had a huge power supply that I had. It wasn't working, you know, it needed a lot of work done to it, but it was a really big Farnell power supply, huge thing, and inside it were these cables. Now this is quite thick cable. In fact, this is really thick cable. This, I would assume, would take 100 amps quite easy. The inside core is not, it's stranded, but it's a very thick strand. There we go. I don't know whether we can see that. That's not going to show. But here you can see it's very thick strand, and this would be pretty good. It's really difficult to bend. It is some real big cable. Now I need to get it here, and the terminals are going to be about here. Now if we grab our back panel, that's the way it's going to be going, okay? And as you can see, our terminals are kind of here and here. All right, so we need, I just had to check then. I haven't even checked to see if these are within the right. Yes, okay, good. That way. Oh, yeah, there we go. I was a bit worried then. So the cables are going to go kind of here. And I'm not sure how I'm going to do this. Now, I've been messing about with this wire here. And I've made a little right angle L-shaped. And I could put that kind of on there and solder it on. Would it work? I'm not sure. I think, because this is really thick cable, so I'm not sure if I'm going to use that. This would be a lot easier, and it might be easier as well getting it into place. It's more flexible, because with the negative wire, I need to go from like here, and I'm going to go underneath most probably with the wire, So it goes underneath and to the bar that's going to go across here. Now, when it comes to the bar as well, taking apart that, I've just lost a part now. There we go, I found it. Right, so taking apart that supply, we have found inside that supply basically little insulators. Now, the bolts that were going through here, if the bolts that are going through this, we could mount on the bottom going through this. Now, this needs a little bit of cutting out, needs a little bit of cutting out, because it doesn't quite fit inside, you know, the hole. Whereas this one does fit. Okay, so the idea is to have this one, because this has got a little lip to it, so it will go through the case and insulate the case with the bolt. So this one will go through here, this one will go this side, and we should then get complete isolation between the case and the bar, if this works. Now, the only problem I think I'm going to get is the amount of space that is going to be needed on this end of it and then this end of it. I'm hoping I'll get enough on the size of the bolt. If not, I may have to go, I don't know, down to B&Q or something and see if we can find a bolt. But we're gonna, you know, we'll have to have a little look on, you know, how we're going to put this together. So I think I'm going to use the more flexible wire, because trying to get the thicker wire onto here is going to be a really big challenge. I don't know whether you can see right here. Right here, right on the edge, is some traces. I'm not sure if they're the same or not, whether that can go under there. I don't want it touching the case really. But we'll figure that one out. So what I'm going to do now is I am going to wire we don't yet. I'm going to wire a new switch onto this bit and some new cable, and then what I need to do then is work out how we're going to do the isolation for the bar. So we'll come back once I've sorted that one out. I may put some of this together and we'll go through it from then. We've got to figure out how to solder onto these, because I've only got a 90-watt soldering iron, a little tiny soldering iron. I have got a heat gun, but I don't want to do any damage to components here, or desolder something, because there's a couple of right here. There's a couple of like SMD like capacitors, resistors, or whatever it is here. So we'll have to figure this out. But once I figure it out, we'll come back and we'll have a little look. So give me a second and we'll be back. Right. So here we have a partly done. So we've now put the switch in and wired the switch into where it needs to be able to turn the supply on. We have the binding posts in. We have the mains wiring in and wired, so it's wired to this. This just makes things a little bit easier. If I need to work on this, I can just pull this out, put it back in. It's nice and easy to work on. And then, as you can see right down here, we have the shunt fitted. Now, the way I've done the shunt is, where am I here now? So, what I said about doing for these, this didn't work because I think they're maybe ceramic. I think they're ceramic, but I tried to drill it out, and this one here shattered. I've actually super glued it, so this one shattered. So we tried to do it again by just gripping it on the edge here, and the edge shattered off, and again I've had to super glue that, as you can see there. So they didn't work. So we've had a little thought. I am going to have to go out and I need to get some sort of insulation, nylon insulating things to go through the bodywork. So the front, it is upside down for you, but we've got the meter here and the switch to turn it on and off here. Now on the underside, as you can see, we have these great big bolts coming through here. Now the ones that originally come with it are these ones, and to do what I was going to do after they broke, that these were too small, so I found some other bolts. Not ideal. I think I'd rather actual proper hex bolts, but we'll refine it as we go along. So what I've done is, as you can see here, if I just get a little pointing tool. So as you can see here, right here is a ceramic insulator. Now what I've done is I have drilled through here. It's quite a big hole. It is roughly, that my battery's run out in this, so we're having to do things a little different. It was about 15, 16, 17. Yeah, it was about 17 mil hole. 16, 17, 18 mil hole. So we drilled a hole straight through, and then I put some electrical tape around part of the bolt, just to make sure it didn't short with the case. Again, like I said, I'm going to get some nylon insulators to a degree, kind of like this type of thing, and the kind of like how the binding posts are done. So we made a nice big hole through, and then on the underside, yeah, can't really see it well, but right here, just under here, just underneath there, you see there's a little plastic spacer. So we've used a plastic spacer to keep it off of the base of the supply, and it is isolated completely from the base, which is good. That's exactly what I wanted. So now I need to make up some wire. So we're going to use this. I'm going to make up some wire, and I need to start wiring in the supply. Sorry, the meter now. But with the meter, I didn't plan putting the bar. I didn't plan very well for putting the bar back here. Ideally, I think the bar should have gone at the front, and then we wire the bit from there, because there's a little one here and a little one here. They need to go on here, but we'll just extend the wires to put it under there. That's not a problem. So we're gonna do some of this wire, and the easy one, the first one, will be the positive, which will come from this post here, and basically we're going to go from here to here. That'll be our first thing. Now I don't know whether the voltage drop is going to be any quite substantial or not. I'm not sure, because this one's obviously going to be short, but this one will go to here and then from here to here. So I'm not sure how, because this one will be potentially be longer than what this one's going to be. So I'm not sure how that's going to work, but I'm hoping it's going to be okay. So what I'm going to do now is I'm going to sort some wire out, hopefully get it on here. I'm hoping my soldering iron is going to be enough to be able to bind these to this, because I don't think, ideally I don't think I want to be doing something like this. No, I don't. No. I'll figure something out. And then we'll come back. Yeah. But so far, it's not going too bad. I'm quite happy with that. I haven't put in yet a plug, a switch. So I think for the switch, because I don't want to make this, I don't want to make it weak. So if I leave a small gap, it's going to be quite weak on the, and it may bend and break. So I may have to leave a little gap and then put the switch here, or we'll put a switch up here. In fact, we may put a switch up here. I may take the live off and go for a switch up here, directly above it, somewhere up here. I think we'll do. But so yeah, we'll sort some cable out and then we'll be back. Right, so the wires are in, the main wires, the live and the negative. Now I used this the red one. Like I said, I was going to use the 2 cable red one that I had, and I found a power supply. Like, you know, I said a pound of power supply, and I'm using that on the negative on this side. You know, this should work perfectly fine. This will certainly handle the 100 amps. With this one should handle the 100 amps quite easily. This one is, I can't remember what gauge it was. It was 105 degrees C also. So yeah, it should handle the ampage that is needed. At the moment, I've not got anything to test it up to 100 amps. So my normal testing radio and such, until I make myself like a load tester. That's going to be another kind of project I want to do. But it is it's all wired up. The negative side here. Now the posts here, they're not brilliant at all. It was really hard to get them soldered because of the copper pads, that the area, you had to really heat it up. I've only got a 90-watt soldering iron, and you had to really heat it up, and it was cooling down quicker than what I could heat it up. So getting them on was really, really difficult. Now I'm open to suggestions on how to do this. If you could give me a hand, I will refine it, later on in time. I may have to get another soldering iron, 150-watt soldering gun or something. I did try to use my heat gun, but it wasn't doing what I wanted it to do. It just really wasn't. And there's some components, this side of surface mount, I didn't want to unsolder them with the heat, So if I go in and show you this bit, there we go. So as you can see, it's a bit harder to see. This is the cable that I found off the power supply, the big power supply. So that's quite a hefty thing. We got the 100 amp shunt. This is the negative post that goes round to the power supply. The positive, and then if you can see, there we go. So as you can see, it's not brilliant. It might be better if we get the microscope onto that. So let's have a right, there we go. So there's the switch. That's for the switch. And then as you can see, this was extremely difficult to get soldered because of the copper plate. So that is really not brilliant. It really isn't. And it took quite some time to do it. But it is on there. It is secured. I have looked with the scope, and there's no bridging of the cables or anything like that. I have actually switched it on to show 13.82 volts. I'm still not sure about the switch yet for this. I'm not sure whether I'm going to put one on or not. Yeah, that one may do it. I was going to put a little light, LED light here to say, to show it's switched on. But again, with that, not too sure, because the meter here will light up and you'll know it's turned on anyway. So the next thing I've got to do now is wire the meter up to the shunt and to the power supply. So that's what we're going to do next. Right. So there we are. The cables are all now on. This one here is the power for the meter, and all we do is we connect the red and the yellow wire together and send that straight to the positive of the power supply. We don't need to connect the negative of the meter, because we are powering it via its own internal supply. If we were using an external supply, say if we were to have a little 12-volt socket here for the meter, then we would need to wire in the black wire. And then this wire here that we can see here, this goes underneath this, and one end, let me get a little pointer, one end goes to here on this little screw here, just where I'm pointing. Wonder if we can, there we go. The little yellow tags right here, you can see. So one end goes to here, which is the red wire from here. And the black wire from here goes to this one here. And that is our finished. It could be refined a little bit better, but that is our finished supply. If we upside down it, there we go. This is the isolated things for the supply. Now comes the moment for turning it on. So I here have mains lead. What we do is we plug the mains lead in here. Now you can't hear it on the video, but when you switch the mains for this, there's a plug down here that I haven't switched on yet. But when you switch the mains in, you'll hear a little tick like a relay in the supply. That you can hear, and then when you unplug it, you can also hear it tick off as well. That may be a bit better when we put a switch in this, which I'm pretty sure I'm gonna do now I've done the rest of this. So we'll turn this on, and I'll tap when I hear the tick. Okay, so that was the tick, and as you can see, the supply, we don't want to mess around. So as you can see, it's upside down for you, but when I switch this on, you'll see on this side there is, if I do that, this little light here. You'll see a little light here. When I switch it on, that will show, that will light. See that? That's all lit. So that's now on. And then when I turn off, it turns it off. Okay. That is how we will know whether the supply, there's something wrong with the supply. If we were to turn it on and nothing was to come on the outputs, we would know whether the supply is something wrong with the supply. So I'm going to hold the bottom here, and we're going to do it from here, because of the binding post at the bottom, you know, kind of here. So when we turn this on, you'll see it display on here. There we go. You can see it upside down, but it says 13.8 volts, and there's 0.0 amps running because there's nothing on it. So yeah, a nice little supply, and then that'll slowly go down and then diminish, just like so. So a nice little supply. Now, there is one thing I'm not sure on, and if somebody could, you know, shout in the comments, it'll be pretty cool. As we can see, all of this, like this bit round the front, is plastic. What it's mounted on, this, or should I say here, this is all metal. So the base here and the front here is isolated between the two. There's no continuity between the two, and the same it is for the back as well. Okay, the only thing, so if I was to put a multimeter diode tester, you know, buzzy noise, on the earth pin, and I was to tap the other end on here, there would be continuity between the two, saying basically it's earthed, right? Now, as you can see, I don't know whether you'll be able to hear it. You can't hear it. Hold on, let me just see if I can turn some stuff down so you can hear it. Turn that off. There we go, so you can hear that. So if I was to go from the earth pin to here, you'll hear the continuity. Okay, that also works for anywhere that I can tap onto, minus the blue paint obviously, but anywhere I can tap onto on the bottom works perfectly well. This screw here works. There's continuity here, but for some reason there's not continuity here. I don't know why, as well as the other pins on the thing. But the bottom has got continuity, and if I was to turn this over and do the same on the bottom, say for instance the screws that are holding the supply in is all continuity, which is perfectly fine. These have got continuity through. That is because on the supply, the negative is also connected obviously to the case. So for the negative here will be connected as well. So the binding posts are connected, so all the earthing for this I think is okay, but I didn't know whether I need to add an extra earth wire. Let me spin this around. Yeah, here. I didn't know whether I needed to put, another bond. So say if we were to make a bonding post to here, and then whether to go from here to here with an earthing cable as same as from here to the front with an earthing cable. I wasn't sure. The same with the lid. The lid, when the lid is on, there is no continuity for the lid because the brackets here. So when we put the lid on, it doesn't touch bottom. It doesn't touch the bottom here. So I didn't know whether to make an earthing bond between here and up here. So, but it doesn't touch this bit neither. There's a little lip here. You can't really see it that well. Yeah, there we go. So if I put this upside down, there's a little lip here, and when the top goes on, the face sits on this, but doesn't touch any of this metalwork. So I weren't sure whether I should be doing that or not. If anybody knows in the comments, let me know, because I certainly would like to know. I'm only not sure because of the insulation between here and here. It's insulated. There's nothing between these two bits here. The back, sorry, here is not connected to this either. So apart from that, shall we have a little fire the radio and have a little test and see what this does? I think that's what we'll do. So now we'll just switch over. I'll take the other power supply, my main power supply, off, and we'll stick this on, and then we'll have a little check and see what it does. Right, so the radio plugged in. Here we have the mains plugged in, and the radio is off at the moment. I have checked with my other power supply. I just want to make sure that I've got, the noise floor is about the same. So I've got this supply just, yeah, there we go, hold on. We put that the right way around, but yeah, that's it. There you go. So we've got this Sherman Multicom 50 amp supply that I normally use. And when I just turned it on, the noise was about an S2 to S3 on 40 meters. So hopefully this, so I am going to bring it up here like this, turn this on. We've got 13.8 volts. Okay. Just want to keep this in here. So we're going to turn it on. There. And we have got about 1.8 amps on receive. And noise level is exactly the same. Yeah, noise level is exactly the same. So let's go and put about here. Now I'm just going to do a CW test and I'm only going to do 70 watt. 70 watt on CW. Okay. I wonder that there's a little noise there. So what I'm going to do is I'm just going to pause, switch over supplies and just check that that's there still. Right, yes, that noise was still there. So it wasn't the supply that did it. So thankfully we are okay. I wonder if we can make this a bit better so you can see. There we go. So as you can see, 13.8 volts and it's 1.8 amps on receive. Now I'm just going to turn that down. So the test we're going to do is 70 watt on CW, and we'll see how what the amperage is. So we shall set for 70 watt and send. Oh no, CW would be good. I didn't do it at CW then. So send. .2 amps. There we go. 15.2 amps. 70 watt on CW. And there is no voltage drop at 15 amps. There might be, actually, because it was set at 13.82 volts. So if I get my multimeter, cheap multimeter, I've had it for absolute years. 13.82 volts. We'll just turn that round. There we go. 13.82 volts and send CW. 13.73. 7.4. So it does drop a little bit on there, though it doesn't say it on this meter here. I'm not sure. I think that's just because it's here and the voltage is being read on the binding posts on the actual supply. So whether there's some loss through the cable, maybe. Let's do 80 watt. $13.73. $90 watt. 13.72. $100 watt CW. 13.72. So let's just check what the 100 watts says on the meter here. 100 watts CW, $18.4, and it still says 13.8, which is a bit strange. Shall we take a little look under the hood? And get the meter. Post here. Says 13.83. So I think there is. Excuse me. 13.78. I don't know why that says 13.8 still. 13.83. I thought I originally set it for 13.84. So, and it's not even. It says 18.5 amps. Okay. We do 70 watt FSK. $13.79. 15.3 amps. That's at 70 watts. We'll turn it up to 80 watts. 7.9, 16.3. 100 watts. 18.4. 13.78. So I think if I was to turn this up a little bit more, it would stay a constant 13.8. I think. What I'm going to do is I'm going to switch over to the other supply. I've never done this, and see if there's how much drop there is with a professional made one. You know, compared to this. So watch out, and we'll be back in just a second. Well, that's strange. So the Sherman that I've always used actually says it's 13.5 volts or 13.55, and then when I turn the radio on, it's 13.5, and then 100 watts, 100 watts FSK, 13.11, 13.1. That's really weird. Okay, I think we're going to wrap this up. I just tested the other supply, and for some reason, let me just get the supply. For some reason, if this sits on, where is it, this side, 13.8 volt switch, on the back of the binding posts, the actual supply is, what was it, 13.55 I think it was, and then 100 watts out of the radio, it then drops to about 13.1 I think it was. And this one, this sits at 13.82, and then the 100 watts FSK then takes it down to 13.72. So this is actually very stable. 0.1. 0.1? Yeah, 0.1 of a volt. So not bad. I think it's 0.1. Let me just check, because I had a little, yeah, not 0.10 of a volt, which works out, that's while I'm drawing 18.5 amps. So at 100 watts FSK out the radio, it's drawing 18.5 amps, and at 18.5 amps it is a voltage drop of 0.10 volt. So that, I think, is a job well done. It certainly can be refined a bit better, I think, but overall, my first attempt, I am very happy with how the design has come out. I did come up against a couple of little bits and pieces that if I had the proper hardware to hand at every single point, then it would have turned out a lot better. But I'm not complaining about this at all. So now I've completed it, I'm actually going to pack it all up, and we're going to take it to my local club and show them, because they know that I've been working on a little project. So yeah, brilliant stuff. That is brilliant. I think it's brilliant. Right, so thank you for everyone for the long-winded video. I know it's been long, but I'm going to be doing another project soon, not yet but soon, where I want to build basically a loading, I don't know, loading capacitor or some sort of load that can handle the 100 watt load, sorry, the 100 amp load that this can take, and then I want to test it and see how see how well we go. So yeah, keep an eye out for more videos. Like, subscribe, and comment it in the comment sections. Like I said, comment on me about the Earth and let me know what you think. I don't know whether you've seen these type of cases. I got it from eBay, like 15, 17 pound or something from eBay. So yeah, like, subscribe, and comment in the comment sections. And as always, we'll see you on the next video. Bye for now.